Maayong buntag and good morning. Today, we will discuss Instant Center. The location of Instant Center, topic number 4. At the end of the lesson, you are expected to describe the concept of Instant Center. Locate Instant Center using inspection method, and locate Instant Center using Kennedy's rule. So what is an Instant Center? An Instant Center is a point common to two bodies in plane motion, wherein the absolute instantaneous velocity in each body is the same. Instantaneous centers are also known as centros or poles. As you can see in the presentation, instant center may be an actual common point, such as found in A, or it may also be a virtual common point as shown in B. There are different types of instant centers. The first one is the fixed instant centers. As you can see in the presentation, link 1 is grounded, and thus point B and point C will rotate about point A and point Z. Whatever configuration you will make for this 4-bar linkage, point A and point B will remain as fixed point of rotation for link 4 and link 2. Such, I12 and I14 are fixed instant centers. The next one is what we call as the permanent instant centers. So unlike the fixed instant centers, our permanent instant centers move when the mechanisms move, but the joints are of permanent nature. I23 and I34 are permanent instant centers. As you can see, even when link 4 and link 2 move, these joints are of permanent nature. Thus, they are permanent instant centers. The last one is the moving instant centers. They vary with the configuration of the mechanism. I13 and I24 are moving instant centers. So depending on the connections of the different links, the location of I13 and I24 will vary. Thus, they are called moving instant centers. So how do we determine the number of instant centers? So for a mechanism containing n number of links, the number of instant centers may be determined by this formula. N is equals to n times the quantity of n minus 1 over 2, where n represents the number of links, the big N is the number of centers or the number of instant centers. For example, in a 4-bar mechanism, there are 6 instant centers. Since in a 4-bar mechanism we have 4 links, substituting this to our formula, we determine that in a 4-bar mechanism, indeed, there are 6 instant centers. So how do we determine the instant centers if they cannot be? So for this 4-bar mechanism, our instant centers are 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. So some of this can be determined by simply inspecting the mechanism, while some can be derived by using a more complicated approach we use as the Kennedy's rule. It states that any 3 bodies in plane motion will have exactly 3 instant centers, and they will lie on the same straight line. So to illustrate how to use these 2 methods, the inspection and the Kennedy's rule, you may follow these steps. The first one is draw an icy circle with the same corresponding number of links. So if you have, for example, a 4-bar mechanism, you may draw an icy circle with numbering it with the same number of links. So that we have 1, 2, 3, and 4. Take note that the numbering doesn't necessarily have to be of equal spacing, as long as they are in order and they are located in your circle. So this is your IC circle. The next one is locate as many obvious instant centers, whether fixed and permanent instant circles, as possible by inspection. Label the ICs accordingly. Connect the corresponding links on the IC circle. The next step is identify a link combination on the IC circle for which the instantaneous center has not been found. Draw a dotted line connecting those 2 link numbers. Number 4, identify 2 triangles on the IC circle with each contain the dotted line and whose other sides are solid lines representing the ICs already found. Extend a line on the linkage connecting the 2 ICs on the triangle. Do the same for the other triangle. The intersection of the 2 extended lines will locate another IC. You may repeat these steps until all ICs are found. So let us try this 4-bar. So you are to locate the instantaneous center. So the first step is to compute using the formula how many instantaneous centers a mechanism has. So this has 4 links. That's why we have 6 instantaneous centers. The next step is to draw the instantaneous center circle and then numbering it with the same numbering that we have for the links. We have 1, 2, 3, and then 4. So we have 1, 2, 3, and 4. The next step is to locate by inspection the instantaneous centers, the fixed and the permanent instantaneous centers. So as you can see here, since link 1 is grounded on the ground, this joint here is also fixed. Thus, the intersection of the intersection of link 2 and link 1 is our instantaneous center I12. And then in your instantaneous center circle, you connect the numbers 1 and 2. The next one is the intersection of link 4 and link 1. Thus, we have instantaneous center I14. So in your instantaneous center circle, you connect I1 and 4. So these are our permanent or fixed instantaneous centers. For the permanent instantaneous center, you can see here that link 2 and link 3 meet at this point here. Thus, this is another instantaneous center I23. In the same way, you connect 2 and 3 in your IC circle. Same also with the intersection of 3 and 4. Thus we have 3 and 4. So now we already have 4 instantaneous centers. Now we need to locate the location of the other instantaneous centers. As you can see here, all we have to think is to create triangles using the numbers that we have. If we connect 2 to 4, connecting 2 to 4, so we will use a dotted line so that we can identify this as the instantaneous center that we wanted to locate. So we wanted to locate the instantaneous center 2, 4, or the connection between 2 and 4. As you can see here, we were able to create 2 triangles with sides 2, 1 and 1, 4. On the other hand, we have another triangle with sides 2, 3 and 3, 4. So we have triangles 2, 1, 4 and triangles 2, 3, 4. So do not mind 2, 4. So let's focus our attention to instantaneous center 2, 1 and 1, 4. So 2, 1 and 1, 4 is found here. And then we also have instantaneous center 2, 3 and 3, 4. So 2, 3, just connect 2, 3 and 3, 4 and then extend the line. So the intersection between these sides are your eye center, is your eye center 2, 4. So now we have 3 instantaneous center. We have now 5 instantaneous center. Now, if you're going to draw another line connecting I13, you can see here that we can create another triangles. So this is the method by which you can find the instantaneous center 1, 3 by making triangles and then looking for the sides of that triangle. So the sides of the triangle 2, 1, 3 or 1, 2, 3 rather are 1, 2 and 2, 3. So locate the line joining 1, 2 and 2, 3. So we have here 1, 2, and then 2, 3. So just extend the line connecting these two instantaneous centers. And then we have 1, 4, and 3, 4 on the other triangle. So 1, 4, so we have here, and then 3, 4. So just connect the line joining these two instantaneous centers. So the intersection of these two lines is our instantaneous center I1, 3. Thus, we have 6 instantaneous centers. So we have 2 fixed instantaneous centers, 1, 2, and 1, 4. 2 permanent instantaneous centers, 2, 3, and 3, 4. And 2 moving or varying instantaneous centers, 2, 4, and 1, 3. So that is how to get the instantaneous center for a 4-bar mechanism. So let's move forward to a slider crank mechanism. So a slider crank mechanism has a slider. So this slider slides along the horizontal. So this portion here is a fixed or ground. We call it link 1. So the other links are 2, 3, and the connection between the slider and link number 3, which is our joint or link number 4. So again, we will draw an IC circle. Of course, we need to calculate the number of centros that is possible for this mechanism. Since we have 6 links, substituting in our formula, we can get 6 instantaneous centers. So that's the first thing that we need to do. And then draw the equivalent IC circle having 4 numbers corresponding to the number of links. So the first thing that we have to do is to locate by inspection the fixed and the permanent instantaneous center. So we do this by connecting again numbers or finding the joints or connections here in our diagram. So the first is instantaneous center 1, 2. So take note that this joint here is grounded to the ground, which is 1. That's why the connection is 1. The next one is 2, 3. To connect point 2 and 3 in your IC circle. The next one is 1, 4. 3, 4 rather, the connection between link 3 and the slider 4. Thus we have 3, 4 in our IC circle. And then take note that your slider is sliding along the horizontal one, and thus your sliding is actually considered as an infinite rotation of the slider along the horizontal. And thus we have instantaneous center I14 at infinity. So thus we have connections between 1 and 4. So these are our instantaneous centers that we can locate by inspection. Using Kennedy's rule, we will use again our technique. So we will try to create triangles using the numbers that we have in the IC circle. So the first one is connecting 2 to 4. Connecting 2 to 4, we can form 2 triangles. We have triangles 2, 1, 4 and triangles 2, 3, and 4. As you can see, this is the common line, and this is the unknown instantaneous center 2, 4. Between instantaneous center 1, 2, 1, 4. So we connect 1, 2, and 1, 4. So this is our 1, 2, connecting it to 1, 4. Sorry, so that is not 1 to 1, 4, since our 1, 4 is actually this line here. So our 1 to 1, 4 is actually between the ground at infinity, and then we have 1 to 1. So parallel to this instantaneous center here. Again, our sliding is considered as an infinite rotation along the horizontal. And then on the other side, we have 2, 3, and 3, 4. So we connect instantaneous center 2, 3, and 3, 4. So we have 2, 3, and 3, 4. Connect these two instantaneous center, and then extend the line, intersect it with the other side of the triangle. So that's why we can locate here our instantaneous center 2, 4. So now we have 5 instantaneous centers. So let's go back to our IC circle. As you can see, we can connect 1 and 3. Thus, the sides of the triangles formed between this instantaneous center are instantaneous center 1, 2, 2, 3, and 1, 4, 3, 4. So for 1, 2, 2, 3. So we have 1, 2, and then 2, 3. So just connect these lines, these points are instantaneous centers. And then we have 1, 4, 3, 4. So as you can see here, this is our 1, 4, and then 3, 4. So this line here is actually the line connecting the two instantaneous centers. So thus the intersection is here, and this is called I1, 3. So as you can see, we have 6 instantaneous centers. We have 2 fixed instantaneous centers, 2 permanent instantaneous centers, and 2 varying instantaneous centers. For our last example, we will consider a 6-bar mechanism. For a 6-bar mechanism, using our formula, we can get 15 centros. So if you're going to list all the instantaneous centers, so we can have 1, 2, we have 1, 3, we have 1, 4, we have 1, 5, and then we have 1, 6, since there are 6 links for a 6-bar mechanism. And then the others, we have 2, 3, we have 2, 4, we have 2, 5, and then we have 2, 6. Continue, we have 3, 4, we have 3, 5, and we have 3, 6. And we also have 4, 5, 4, 6, and finally we have 5, 6. So counting this, we have 15 instantaneous centers. So we are going to locate the locations of all these instantaneous centers using the method that we already know. So this is our mechanism. As you can see here, by inspection, we can already identify some instantaneous centers. We have first instantaneous center 1, 2. That is the connection between the ground 1 and your link 2. So that's why we have here 1, 2. The next one is the connection between 2, 3. So that is I, 2, 3. So again, you connect 2, 3 in your IC circle. As you can see here, we have 6 numbers in our instantaneous center circle because we also have 6 links. The next one we have, as you can see here, it is a combination of links 3, 5, 5, 4, and 4, 3. So this point has 3 instantaneous centers, namely we have 3, 4, 4, 5, and 3, 5. So you connect 3, 4, 4, 5, and then 3, 5. So now we have 5 instantaneous centers. We have 5 more. So we have another one here. The connection between the ground 5, the ground 1, and then the slider 6. So we have, so it's actually link 5 first, and then the point at the slider we have 6. So we have 5, 6, and then between the ground here. So this is a ground. All ground are numbered 1. So as you can see here, all the ground, they are numbered 1. So this is actually the center between the ground and point 6. So that's why it is at infinity. So between 6 and 1. And then the last one we have 1 and 4. So these are our instantaneous centers that we can locate by inspection. So for the remaining instantaneous centers, we will use the triangle method of the Kennedy rule. So you can choose which point you will connect. All you have to bear in mind is that you need to create 2 triangles. So if we connect, for example, 6 to 3, we cannot create 2 triangles, but 2 trapezoids. So it's not a good idea to select 6, 3 first. How about 2, 5? Same also, we cannot create triangles between the 2 sides because we can create trapezoids again. So the best option to start with is to connect. For our first connection is 1 and 3. We connect 1 and 3 because, as you can see here, we can create 2 triangles between 1, 4, and 3, and 1, 2, 3. It's very obvious then that the location of the instantaneous center 1, 3 lies at the intersection of instant centers 1, 2, 2, 3 and 1, 4, 4, 3. So we'll locate the location of 1, 2, 2, 3 and 1, 4, 4, 3. As you can see here, we have 1, 2 and 2, 3. So this is the line joining these 2 instantaneous centers. And then for 1, 4, 4, 3. So we have 1, 4 here, and then 4, 3 here. So these are the points connecting these 2 instantaneous centers. Extending these lines so we can locate the intersection here. So this intersection will be known now as our instantaneous center 1, 3. So now we have instantaneous center 1, 3. So the next step is to find again another triangle. Two triangles with which the unknown instantaneous center is the border or the common line. So we will select 1, 5. As you can see here, if we connect 1 to 5, there are two triangles that can be formed. We have 1, 6, 5. And then we have 1, 4, 5. Thus, the location of 1, 5 is on the line, is on the point intersecting 1, 6, 6, 5 and 1, 4, 4, 5. So we locate the locations of 1, 6 and then 6, 5 first. So our 1, 6 is here, and then we have our 5, 6 here. So the intersection of this infinite line and this point is a straight line passing in that direction. And then for 1, 4, 4, 5. So we have 1, 4 here, and then 4, 5 here. So this is the same line. As you can see, the intersection between these two lines is at this point. So this is our instantaneous center 1, 5. So the next instantaneous center you can locate by finding another triangle in your IC circle. So let's connect 2 and 5. If you connect 2 and 5, you can see that we can form triangles 1, 5, 2 or 5, 1, 2 and triangles 5, 3, 2. Wherein our instantaneous center 5, 2 is located. So we will go back again to our diagram. We need to locate 5, 1. So this portion here, and then 1, 2. So our 5, 1 is this point, and then we have 1, 2 is this point. So we just connect these two lines, these 2 points. And then find another one which is 5, 3. So 5, 3 and then 3, 2. So 5, 3 is here. So it doesn't have to be in order. You just have to write first the smaller number and then the higher number. And then 2, 3 here. So the intersection is actually this point. So this is our point, instantaneous center 2, 5. So we now have instantaneous center 1, 2, 2, 3, 2, 5, 1, 5, 1, 3, 1, 6, 5, 6, 3, 4, 4, 5, 3, 5, and 1, 4. So let's find the other instantaneous center. So let's connect 3 to 6. So connecting 3 to 6, we have here the common line and the instantaneous center. We have 3, 6. And the triangle that we can find here, we have 5, 6 or 6, 5, 3. And then another one, we have 6, 1, 3. So just like what we did, so let's just connect 6, 5, 3, 5 or 5, 6, 3, 5. So 5, 6, and then 3, 5. So this point here, this line, and then we have 6, 1, and 1, 3, or 1, 6, 1, 3. So 1, 6 is here, this infinite line, and then we have 1, 3. So where is our 1, 3? Okay. So here is our 1, 3 here. So 1, 6, and 1, 3. So just connect 1, 6, and 1, 3. So now, since this one is intersecting with an infinite line, so we're not to intersect this point and this point here, but for this case, if the other line is an infinite line, we will have to draw a parallel line to that infinite line. So that's why the intersection is actually at this point here. So this is our 6, 3. So that is what you're going to remember if you have an infinite line. So this one is infinity again because the sliding is considered as an infinite rotation at a point. So thus we have Instantaneous Center 3, 6. So I think we have another one, 2, 6. So for 2, 6, so between 2, 6, we will find two triangles at the border. So we have 6, 1, 2. And then we have, we have 6, 3, 2. So first we have 1, 6 and 1, 2. So this is our 1, 6. This is an infinite line again. And then we have 1, 2. So this is our 1, 2. So we just have to create parallel again to 1, 6. And since this is an infinite line, then we have 6, 3, or 3, 6, 2, 3. So 2, 3 here, and then we have 3, 6 here. So just connect these 2 points. So somewhere here is our instantaneous center 2, 6. So yeah, so we have 15 instantaneous centers. And then you can also find another one if you connect 4, 5. So with the same process, and then you can also find 2, 4. So these are our 15 instantaneous centers for this configuration that you can see in this particular example. So if you have some clarifications or questions, you are free to ask me during our consultation, or you may watch this video which I curated. While watching this video, I want you to find out how to use the method of inspection using the video and using the triangles to find the other centros, and focus only on the method of finding centers and not yet on finding velocity or acceleration. So that's all for topic number 4. See you in our consultation. God bless us all.